In October of 2017, astronomers witnessed something truly extraordinary. It was the first time in recorded history that a visitor from another star system was detected passing through our solar system. This strange object entered at an incredible speed, tumbled through the void, and then vanished just as quickly as it had appeared. It didn't follow the patterns of a typical asteroid or comet. Its path was hyperbolic, meaning it came from outside the gravitational influence of our Sun and was not coming back. The object was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, a name that perfectly captured the sense of mystery and wonder surrounding its appearance. Initially, astronomers assumed it might be a standard comet or asteroid, albeit one with an unusual trajectory. But as they began studying its characteristics in more detail, it became clear that Oumuamua was unlike anything they had ever seen before. The first clue was its shape. Based on how it reflected sunlight while spinning, researchers concluded that it must be either extremely elongated, like a cigar, or flat, like a pancake, at least 10 times longer than it was wide. This ratio was unprecedented. No other naturally occurring object in our solar system exhibited such proportions. Then came its motion. Unlike most celestial bodies that rotate smoothly, Oumuamua tumbled unpredictably through space, as if it were flipping end over end. This tumbling motion made it difficult to study, but it also added to the strangeness. However, the most intriguing aspect of Oumuamua's behavior came after it passed closest to the Sun. As it moved away, instead of slowing down as expected under the Sun's gravitational pull, it began to accelerate. This kind of acceleration usually indicates the presence of gas being released from a comet, a process called outgassing. When ice in a comet sublimates due to heat, it releases jets of gas that can propel the object forward. But despite careful observation, no such gas or dust was detected around Oumuamua. This created a puzzle. If it was accelerating like a comet, why didn't it show any of the signs? And if it wasn't a comet, what could explain the movement? Scientists began exploring every possibility. Some proposed that it could be a fragment of nitrogen ice, chipped off the surface of a Pluto-like exoplanet somewhere far away. This would allow for sublimation and acceleration without a visible tail. Others suggested it might be made of hydrogen ice, which would sublimate invisibly and could explain the lack of detected gas. But hydrogen ice is incredibly fragile and would likely not survive a journey across interstellar space. Despite these efforts, no natural explanation seemed to fit all the observed data. That's when a more unconventional idea began to surface. Avi Loeb, a theoretical physicist from Harvard University, put forward a bold hypothesis. What if Oumuamua was not a natural object at all? What if it was artificial, perhaps even a probe sent by an extraterrestrial civilization? Loeb's reasoning was based on several points. First, the strange shape of the object was consistent with what you might expect from a solar sail. A thin, wide structure designed to harness the pressure of sunlight for propulsion. Second, the unexplained acceleration could be explained by light pressure, which would affect such a structure. And third, the lack of detectable gas or dust suggested that it wasn't behaving like any known comet or asteroid. Loeb published a scientific paper on his theory, and later expanded on it in his book, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. His claims made headlines around the world. Some scientists praised him for thinking outside the box, pushing the boundaries of what we're allowed to ask. Others criticized the theory as speculative, pointing out that extraordinary claims require extraordinary evidence, and there was, as yet, no direct evidence of alien technology. Nonetheless, the idea that Oumuamua could be an artificial object resonated with the public imagination in a way few scientific discoveries do. It posed questions not just about the object itself, but about humanity's place in the universe. Regardless of what Oumuamua actually was, its discovery had a profound impact on astronomy. It confirmed that objects from other star systems do occasionally pass through our solar system, something that had long been suspected but never observed. It also revealed how unprepared we were for such an encounter. By the time we spotted Oumuamua, it was already moving away from Earth at high speed. We had only a few short weeks to observe it, and the data we managed to gather was limited. We didn't get a clear photo. We couldn't launch a probe to study it. We were spectators to a cosmic mystery we couldn't fully grasp. Since then, astronomers have been working on ways to be better prepared for the next interstellar visitor. In 2019, another such object was spotted, Comet Borisov, clearly cometary in nature and more familiar in its behavior. But Oumuamua remained unique. With new observatories like the upcoming Vera C. Rubin Observatory, we'll soon have the tools to detect these fast-moving visitors earlier, perhaps even early enough to study them in real time or intercept them with spacecraft. Today, Oumuamua is far beyond our reach, traveling silently through the darkness of interstellar space. It may never be seen again, but it left behind a legacy, a mystery that challenges our understanding of what exists beyond our solar system. Whether it was a shard of interstellar rock, a bizarre ice fragment, or something engineered by intelligent life, Oumuamua forced us to confront the vast unknown that surrounds us. It reminded us that the universe is still full of surprises, and that sometimes reality is stranger than fiction. And perhaps, somewhere out there in the deep night, another visitor is already on its way, carrying with it answers we have yet to even imagine.